Hey guys, this is Mr. Bennett, and this is video 9-3. Now, in 9-3, we're going to talk about something called molar mass. And what it does is it takes the concept of a mole, which is something we introduced before winter break, and combines it with the idea of mass, which we've been talking about pretty much all semester long. Okay, so let's look at the first example here. So it says, calculate the molar masses using the periodic table. Okay, well technically number one doesn't really want the molar mass yet, so don't deal with that. Don't get worried about this term yet, okay? So they simply want the gram atomic mass of neon. So right off the bat, this tells us that we need to look for the atomic mass. And what particular element? Neon, okay? So we can do that by going to the periodic table. Easy enough, right? So you go to the periodic table, neon is over here, it's a noble gas, right? Its atomic mass is 20.18. Now before break, we talked about when we use these atomic masses, we round them off to the nearest whole value. There's only one exception, right? Chlorine over here, we round off to 35.5. But we want neon. So neon has a mass of 20.18. We're going to round it off to 20. Now in the past, we've said that the units of this would be AMUs, atomic mass units. Okay? But it turns out atomic mass units are actually more of a modern value or a modern unit for this number. And it turns out this number is actually also equivalent to grams for every mole of that substance. In other words, we could also take this number and we could write it this way. We could say that 20 grams of neon is equal to 1 mole of neon. Okay, so this is what we mean when we say gram atomic mass. Okay, we simply want the grams. We take the number from the periodic table and we give it grams as units. Okay, and that's going to tell us the mass of 1 mole of that substance. It doesn't matter what substance you're talking about, whether it's iron. Iron has a mass of 55.84, so a mole of iron has a mass of 55.84, or if we round it off, 56. Okay, so for this particular answer, for number 1, this is what we're looking for right here. 20 grams of neon equals 1 mole of neon. Okay, so you go back here. Again, 20 grams of neon equals 1 mole. Okay, so that is the gram atomic mass. The units should be grams. Okay, now let's talk about molar mass. Molar mass is going to take this idea and take it one step further. So let's look at molar mass of potassium. Okay, if you've forgotten, potassium is K on the periodic table. So let's go back to our periodic table. Potassium is right here. Its mass is 39.098. We're going to round this off to 39. So that would be 39 grams of potassium equals 1 mole of potassium. Okay? Now, another way of thinking of this is for potassium, right? If I have 39 grams, right? So ignore that. So 39 grams, right? That's 39 grams per mole, right? Because it was for every mole, it's 39 grams. So this is what we call the molar mass. Okay, all we're doing is we've simply taken this and we've simply said, okay, I know that 39 grams equals 1 mole, so that means that every mole is really 39 grams, so it's 39 grams per mole. Okay, so all we've done is we've taken the same number and instead of giving it units of grams, we've given it units of grams per mole. That's it. Okay, so not really that more complicated. Okay, all you have to do is pull the number off the periodic table, right, and write it as 39, in this case for potassium, and give it units of grams per mole. This is what makes it molar mass. Okay, and it's just a way of thinking of it as the mass per mole. That's all molar mass really means. Okay, so let's look at this for water then. Water is a compound. Neon and potassium were elements. Now let's look at how we do this for a compound like water. Well, I don't need to go to the periodic table for these values. I know that hydrogen has a mass of 1 on the periodic table, and I know that oxygen has a mass, equal sign here, has a mass of 16. Okay? So what I do need to do though is I need to account for the number of each atom in the compound. So hydrogen, there's 2 of them, so when I add them together I need to make sure I add in the mass of 2 hydrogens and then the mass of 1 oxygen, so that'd be 16. Okay, so 1 plus 1 gives me 2, plus 16 gives me 18. Okay, and then my units, I need to be careful here. So let's look. They want the gram molecular mass. Well, that just means I give it grams, so it's 18 grams of water equals 1 mole. Easy enough. Okay. So when you're trying to figure out what are the units going to be, well, if it's molar mass, it's always going to be grams per mole. If it's gram molecular mass, if gram is in the name, the units are grams. Okay, so let's look at this for two slightly more complicated problems. So here we have barium hydroxide. Barium, the reason why I know this is called barium hydroxide is that barium is a metal, okay, and then OH is one of our polyatomics that we've memorized. OH is hydroxide. It's also known as a polyatomic ion. Okay, and what does that tell us? Well, it tells us that this is an ionic compound because it contains an ion, in this case, hydroxide. Okay, so I'm going to skip ahead here for a second. What's the name? It is barium hydroxide. Okay, just to review, for the naming of ionic compounds, you take the metal, you simply write out the name of the metal, in this case barium, and then you name the polyatomic ion hydroxide. If this had been an element instead of a polyatomic ion, like chlorine, we would change the end of it to chloride. Okay? Alright, so let's go back here. We didn't answer these. It says how many of the atoms are in this particular compound? Well, barium has a subscript of 1, so that means 1 barium. Oxygen has a subscript of 1 as well. However, this 2 outside the parentheses means that we actually have 2 hydroxides, or what we do is we multiply in. So 2 times 1 means 2 oxygens. And then hydrogen also has a subscript of 1, so I got 2 times 1, which means 2 hydrogens. Okay? So the final question, or the final part of this question, wants me to take the mass of all of these atoms, all 5 atoms here, combine them together to come up with the molar mass of barium hydroxide. Okay? Well, that means that I need the mass of barium, I need the mass of oxygen, and I need the mass of hydrogen. Well, I know oxygen is 16, right? And I know hydrogen is 1, but we need to go to the periodic table to figure this one out. Okay? So let's jump to the periodic table. Barium is right here. It's 137.33. So we're going to round this off to 137. Okay, and so that means we can go back to our problem here. There's 1 barium, so I'm going to take 137. I'm going to add that to 2 oxygens, so that's 16 plus 16, and then add that to 2 hydrogens, so that's 1 plus 1. Okay, so 137 plus 16 gives me 153, plus 16 is going to give me 169, and then plus 2 is going to give me 171. Okay, what are the units? Well, okay, they were asking for the molar mass. Remember, anytime they want molar mass, that's grams per mole. Okay, so it's 171 grams for every mole of barium hydroxide. Easy enough. Okay, last problem. Now, this is also an ionic compound. I want to point out something here. We have a metal, just like up here. Barium is a metal, calcium is a metal, and then it also turns out that this is another polyatomic ion. Okay, so skipping ahead to the name again, anytime it's ionic, you name the metal first. You simply write out its name. In this case, it's calcium, and then you name the polyatomic. In this case, it's nitrate. So calcium nitrate. Ionics are the easiest to name because you simply just name the 2 parts. Okay. Now let's count up these atoms. Subscript of 1 again on the metal, so that's 1 calcium. Subscript of 1 on the nitrogen, so 1 times 2 gives us 2 nitrogens. Subscript of 3 though on the oxygen, so 3 times 2 gives us 6 oxygens total. Okay, a lot of oxygens to deal with, so we want to make sure that we take care with those. Okay. Now, as far as masses go, we need to know the mass of calcium. To answer B here, we need to know the mass of calcium, we need to know the mass of nitrogen, and we need to know the mass of oxygen. Oxygen we already know has a mass of 16, but the calcium and the nitrogen we need to look up. So let's jump to the periodic table here. Calcium is right here, it's 40.078, so we're going to round that off to just 40. And then nitrogen is up here, it has a mass of 14.007, so we'll round that off to 14. Okay. Now, question B is saying, what is the gram formula mass? So we're going to add it up. Okay, so there's 1 calcium. Each calcium has a mass of 40, so we're going to put 40 in our problem once. Okay, nitrogen, there are 2 of them. So we're going to add in 14, which is the mass of nitrogen over here. we're going to add that in twice because there's 2 nitrogens. Okay, so all we're doing is we're taking the number of each element. Okay, that'd be like an atom of calcium. Well, that has a mass of 40. 2 atoms of nitrogen, they each have a mass of 14. Now with the oxygen, there's 6 of them. So I could write out plus 16, right, 6 times. However, that's a lot of work, and I'm not sure that I want to add 16 6 times. So instead, what I'm going to do is I'm going to do 6 atoms of oxygen times a mass of 16 each. So I know that I'm going to multiply these and then add them in. Okay? So we want to come up with an answer here, but I'm going to do things a little separate here. So first I'm going to add the 40 to the 2 14s. Okay? So 40 plus 14 is going to give me 54, plus another 14 is going to give me 68. Okay? And then I want to figure out what I'm going to add that 68 to. What is 6 times 16? So I'm just going to do a little multiplication over here. So 16 times 6. 6 times 6 gives me 36. Okay, do my little 0. 1 times 6 gives me 6. So that's 36 plus 60, which gives me 96, right? So 6 times 16 is 96. 68 plus 96, I add those two together. That's going to give me 164. Okay. So the last question is, what are the units? Well, they want gram formula mass. Anytime you see gram in the name of the mass that they're asking for, that means you simply just give it a unit of grams. So it'd be 164 grams equals 1 mole of calcium nitrates. Alright, so that is how you do this. Make sure that you complete the whisk online, and make sure that you come up with a hot question for this video. We'll see you tomorrow.